Hi folks, Mr. Long here. I'm going to do some questions on transformations. So let's first of all look at this problem here, this question here. Solve 3f at 2 bracket x minus 1 equals 0. Well, I guess the first thing we need to do is to find our f at x. Okay, so there's our f at x curve, and here's the equation we need to solve. So we'll just solve it using, in the beginning, inverse operations, right? So if I'm going to solve this equation, first thing I'm going to have to do is to divide by 3, and that will get rid of that 3, and then I'm going to be left with f 2 bracket x minus 1 equals 0. Okay, well, I do have the graph of f down here, so let's take a look at it. So I've got two spots where, oh, by the way, that's a y value. That's 0, okay? And so I need to find on the graph of f where the y value is 0. There and there. So for this sake, let's just do this one, okay? So I know that f at 4 is 0. So I do know that this is true. F at 4 equals 0. So if I take a look at this, right, I've got f, 0, 0. Clearly, this has to also be equal to 4. Okay, so what do? I set 2 bracket x minus 1 equals 4. How do I solve that equation? By the way, pause, rewind, etc. First thing I'm going to do is divide by 2. That gets rid of that. Then I have x minus 1 equals 2. And the next inverse operation is to add 1. X equals 3. Okay, so what does that actually mean? Well, it means this. That when I transform f that way, then, and I want to find the x-intercept at 4 would become 3 on this transformed function, okay? And I can do the same thing by putting 0 in here too, right? Because f at 0 also equals 0. Okay, folks, so that's how you solve an equation with a transformation.